Have you ever looked at your own hand and wondered, what if I told you it's almost completely empty space? Not half, not most, but 99.99999% empty. So the real question is, what's actually there? Take a glass of water for a moment. It looks calm and still, but if your eyes could shrink down a trillion times, you'd see a chaotic storm, tiny particles racing, colliding, and never resting. Everything around you, including this simple drop of water, is built from the same basic idea, the atom. Now, let's go a little deeper. Imagine an atom like a tiny solar system. At the center sits a dense nucleus packed with protons carrying a positive charge and neutrons with no charge at all. Orbiting around them are fast, lightweight electrons, constantly in motion. But wait, there's a twist. If the nucleus were the size of a marble, the electrons would be swirling around more than 100 meters away. That's how much empty space exists inside every atom. Here's something even more interesting. The number of protons an atom has is its true identity. 1 proton, hydrogen. 6 protons, carbon. 8, oxygen. Change the number of protons and you don't just modify an atom, you create an entirely different element. But electrons, they're the real storytellers here. They decide how atoms behave, how they bond, how they react, and why materials act the way they do. The shine of a metal spoon, the dissolving of salt in water, the spark of electricity. Almost every property of matter comes from the movement and behavior of electrons. Let's go even deeper for a moment. Atoms can exist in hidden versions called isotopes. Same number of protons, different number of neutrons. Carbon always has 6 protons, but some carbon atoms have 7 neutrons, some have 8. Chemically, they behave almost the same, but physically, they can be stable, unstable, or even radioactive. These isotopes help us date fossils, diagnose diseases, and even power certain types of energy. Before we wrap this up, there's one more twist. Touch your desk. It feels solid, right? But the atoms in your hand and the atoms in the desk never actually touch. Electrons repel each other, creating the sensation of solidity. So technically, you've never touched anything in your entire life. You've only felt forces, not physical contact. And now that you know atoms are mostly empty space, electrons control almost everything, and isotopes are the hidden versions, there's one big question left. How do electrons arrange themselves around the nucleus? And why does that arrangement change everything about an element? That's exactly what we uncover in the next video. And trust me, once you see how electrons organize themselves, the entire world of chemistry starts making sense.